Yeah. Yeah. Good evening, all. So myself, I'm Vijay. I hold like nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment, right? So as part of today's demo, just I'm going to cover the following topics. Right. What is Apache Spark? Why PySpark? Need for PySpark? So most of you have got queries like Spark, Python using Scala, Spark with Python and Spark with Scala. The difference between this Python and Scala, right? Yes. PySpark features, and real-time usage of PySpark, where it is used, and PySpark job market currently, right? Yes, this is. Spark, Apache Spark, right? I define, okay. It was developed by the personality who developed Spark. Meta is a area in AMP lab. Right? It was open source. Spark was open sourced in the year 2010. Yes, Spark was open sourced in the year 2000. Spark, it was developed in the year 2019. Second. It was developed in the year 2009. It was open sourced in the year 2010. And it was donated to Apache Software Foundation in the year 2013. And this is used for big data analysis, processing, and computations, right? Yes. So I defined Spark in 5 lines, right? I defined Spark in 5 lines. So it is a open source distributed execution framework, cluster computed with in-memory computing, with parallel process style. Means you see parallel processing, in-memory computation, cluster computed, and distributed execution framework for large-scale data processing. Right? Yes. Yeah. Spark can be coded with multiple languages. So before I start, right, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Is my voice clear to all?
Yeah, we can hear you.
Fine, thank you. So Spark can be coded with multiple languages, see like Scala, Python, Java, and R language. Spark can be coded with Scala, Python, Java, and R language. Yes. By default, Spark built by using Scala language. Okay. And today, like Python is also mostly preferred. So here Python is also mostly preferred. Is my screen visible to all, right? Some of you are saying that screen is not visible. Visible, right?
Yeah, we can see you.
One second. Fine. So it's a open source distributed execution framework, cluster computed, and in-memory computation, parallel process style. But in the case of Hadoop, we are not going to see this in-memory computation, right? Here, in-memory computation means within the memory level storage, within the memory level processing the data. Spark can be coded with Scala language, Python, Java, and or language, but mostly used ones are Scala and Python. Today, like using Spark with Scala and Spark with Python, mostly preferred. So why PySpark? So why PySpark, right? It's a PySpark is a Python API to use Spark. For using Spark, right? Python is an API. I can say it's a lightning fast technology that is designed for fast computation. Yes. And it is one of the demanding tool among the data engineers, right? To work with bigger data sets. Okay. So why PySpark means for huge data processing for bigger data sets, right? It's one of the demanding tool among the data engineers, right? Yes. So it's a lightning fast technology as data is increasing enormously. We see from the last 10 years, the huge data is getting generated, right? In GBs, TBs, or petabytes of data. But to process the data, we need to have a very fast processing technologies like PySpark. Okay. PySpark is used for distributed SQL, for creating data pipelines. So PySpark is a data flow language. Data flow is a data flow, right? Means the output of one will be the input to the next flow. The output of that will be the input to the next flow. The output of the current flow will be the input to the next flow. In this way, right? It's a data pipelines, data flow, we say, right? Ingesting data into database and ML algorithms. For machine learning algorithms, right? Python is one of the best choice, and PySpark has got many APIs for this machine learning algorithms, right? Even for graph algorithms and for data streams and for iterative. Most of that machine learning algorithms are iterative in nature. If you are applying, right, a technique, you will get some error. So you will keep on applying, you keep on iterating until the error becomes zero, right? So some of the PySpark packages, right? PySpark is a PySpark.sql, PySpark.streaming, and PySpark.ml, and PySpark.machine learning ML lib, right? Spark and Python. Spark execution model with Python is a programming language. Combined together, we say like PySpark. And if you see the difference between Spark implementation using Python and Scala. So Python is dynamic typed. Python is a dynamic typed one, right? So what value you are assigning? What value you are assigning, right? Based on that. Okay. Python and Scala. Python is dynamic type. Means dynamic type means if you are assigning some value to a variable, what type of variable? X means integer variable getting created. What value you are assigning? Based on the value assigned, right? The variable X is created dynamically. Based on what value you are assigning? Based on the value assigned, the variable Y is created. Based on what value? That based on that, the variable Z, right? It is a list, it is a float, it is a int. How you are saying? Based upon what value you are assigning? Compulsorily we need to assign some value, right? Based on the value assigned only, the variables are created dynamically here. Python has got a huge community, right? As compared with Scala, Python has got nearly thousands of modules, like 89,300 modules. Python contains powerful libraries for machine learning graph as compared with Scala. Scala also has got support for all this machine learning for all this, right? Scala has become powerful, especially from the Spark 2 version onwards. But as compared with Python, right? Yes. PySpark features, right? In-memory computation. PySpark features in-memory computation means storage and processing happening within the memory level only. In-memory computation. Second one is lazy evolution, right? PySpark, one more feature is lazy evolution. The data flow gets executed only when we perform an action. Data flow gets executed only when we perform a action. Means just like Python functions, right? If we make a function call, then only function executes. What do you mean by active evolution? What do you mean by lazy evolution? Active evolution in the sense, when defined in itself, execution should happen. Then and there, the execution happening. Lazy means if you perform any operation, then only it executes. Otherwise, it won't execute. If you make a call to a function, then only it executes, right? Otherwise, the function won't be executed. Means Spark is a data flow to execute, right? We need to perform any action, then only it executes. That we call it as lazy evaluated. Fault tolerant means in a Spark, the data is distributed across these multiple RAMs of multiple slaves and are processed parallelly. During this processing, if any one slave goes down, right? Then if any one slave goes down, then how Spark is able to overcome this? Means it has got powerful fault tolerant model. It can rebuild the data, it can re-execute without the job failure, right? Yes. Persistence means next one more feature of PySpark, persistence. Transformations can be reused. We no need to again write the code for this. We can reuse the already output of, you can take the output of already executed transformation, right? Instead of again re-executing the same transformation again and again, you can take the output of the already executed transformation to perform operations. That's what we call persistence. Distributed, right? Yes. And parallel process style. And what is the real-time usage of, okay, parallel processing, data distributed across multiple RAMs of multiple slaves and are processed parallelly, right? Yes. Real-time usage of PySpark in the commercial sector, right? In healthcare, in entertainment industry, right? One second. So here, one second. So here a large amount of data is generated both offline and online, right? This data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful business information, right? So we need to extract necessary data. We need to extract the useful patterns from this raw data, right? We need to have some more efficient tool performing these types of operations, right? So there are some various tools already available, but they're not that much of appealing, right? So to perform multiple tasks on the huge data sets, the tools are not so much up. So we need to have some scalable and flexible tools to track the big data and gain benefit from it, right? So PySpark is one such kind of technology, right? Just got flexible options to perform this huge data to be processed in quick time. So combination of Python and Spark would be the very efficient way for the world of big data. That's why Apache Spark community came up with a tool called PySpark That is the Python API for Apache Spark. So I was just talking about the real-time usage of PySpark means in the commercial sector. So Spark is used for a real-time processing, right? If you talk example of commercial sector, banks and financial fields are using Spark to retrieve the customer's social media information, social media profile, and also gaining some insights, useful insights from that, which can help to take the right decisions, right? And even in the healthcare, right, to track the patient's records along with the previous medical history, right? Identify which kind of patient, which patient is probably to face the problem or face the health issues even after being discharged from the clinic, right? Yes. And even for entertainment industry, right? Even in the entertainment industry, the famous entertainment is one of the most largest sector, right? So the popular online platform like Netflix using Apache Spark for real-time processing. So processing that personalized online movies, web series. Nearly it is going to process 450 billion events per day that are streamed over the server side application, right? And even in the e-commerce industry also, right? For advertising, Apache Spark is mostly preferred. Websites like even if you talk about the e-commerce sites like Flipkart, Amazon, right? Recommendations, lot of recommendations techniques are applied, clustering techniques are applied, right? Even in the tourism industry, which uses Apache Spark to provide advice to millions of travelers by comparing hundreds of tourist websites. Okay, so here even if you talk like the speed of Spark, right, as compared with other technologies, right? So if you talk Yahoo has taken a table. Yahoo has conducted a test to check the speed of various databases, right, by taking a table of 100 TB consisting of 1024 columns, right? Yes. So sorting, what is the task? Sorting based on 16 columns. What is the time taken, right, by different databases? So Oracle has taken 3.5 days. MySQL has taken 6 days to process this. And Teradata is a specialized database used for data warehouse purpose. So it has just taken 4.5 hours, right? But there is one more specialized database used for data warehouse purpose. Netija has taken 3 hours. And finally, Hadoop has just taken 3.4 minutes, right? Hadoop has just taken 3.4 minutes. That is what the speed of Hadoop. But compared to Hadoop, Spark is 100 times faster than Hadoop. Spark is 100 times faster than, then see, check the speed of Spark. PySpark mainly designed for batch applications. PySpark mainly designed for batch applications, for iterative algorithms, interactive queries, and for streaming. Right? Okay. So as part of this course, right, I'll be discussing in brief about this various. So before I go further, right, I'll be taking for 1.5 hours. The session will be goes for 1.5 hours. But before that, let me show you what is the course content I will be discussing as part of this. PySpark is providing many built-in functions. We no need to write huge codings here. So it has got many modules, functions available, many APIs available, right? So just observe this. Just observe the PySpark. That is the course content I'll be discussing in brief, right? Yes. What is Apache Spark, PySpark, need for PySpark? So difference between this and real-time usage, PySpark applications creation sessions and PySpark session, Spark context object parallelizing, repartition, broadcast variables up and accumulators, right? Yes. PySpark RTD computations, persistence options, right? Memory only, disk underscore SCR only, memory and disk only, right? PySpark core computing, PySpark core computing, right? Yes. Fault tolerance model in Spark. Different ways of creating RTDs and aggregations, increasing the number of partitions, groupings and aggregations, different groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, reduce, and of various other transformations. Various actions and transformations in brief, like count by key, count by value, sort by key, zip function, union, like distinct, and various other operations like inner join, outer, Cartesian, co-group, right? We don't need to write tasks here, like predefined transformations available. We can apply them and can get the result. PySpark SQL data frames are more important, widely used today. PySpark SQL data frames concept, making the data structures and making a data frame creating by using this. Okay, data frame APIs available, creating a data frame, creating empty data frame, right? Converting RTD to data frame, converts data frame to pandas. How do we can convert a data frame to pandas? PySpark show function, struct type, row class, column class, select, collect with column renamed, right? Where filter, drop and drop duplicates, order by, sort, group by, join, union all, union by name, UDTF, right? Map, flat map for each sample, fill nulls, right? Pivot, partition by, all this, right? And PySpark SQL functions are available, especially like aggregated functions, window functions, date and timestamp related functions, JSON functions, right? Read and write into JSON file. Okay. And if I talk about PySpark built-in functions, various built-in functions, right? When expr, lit function, split function, concat, right? Substring, translate, all are they look simple, right? Very less coding, and regular expressions to timestamp, to date format, date diff, months, explode, right? Array, collecting list, create map keys, map value, struct. So a lot of functions, all this I'll be discussing in brief, right? And PySpark external sources. So we can create data frame in different ways, right? Working with SQL statements. So also I'll show you some kind of integrations, right? Spark and MySQL integration, Spark and Hive integration, right? Spark working with CSV files, working with JSON files, transformations and actions on data frames, narrow and wide transformations, adding of new columns, dropping of columns, renaming columns, adding of rows, dropping rows, handling nulls, window functions, right? And also I'll be discussing about the deployment modes, local mode, clustered mode, right? Cluster and standalone mode, right? Okay. PySpark application, right? Yes. PySpark application, stages and tasks, drivers and executors, building Spark application, pipelines, deploying Spark app.
करना एक मिनट
This be in mute.
बंद कर लो
Right. Building Spark applications or pipelines, deploying Spark applications to cluster and tuning and performance tuning and perform PySpark streaming concepts. Okay. Integration with Kafka, other things, right? Yes. Okay, fine. So this is what in brief, in depth, we'll be discussing a lot of topics I am going to cover, right? Can compare the syllabus with any other training of PySpark. You can see how brief will be, our depth will be going, right? With each and every functionalities of Python. What is that PySpark core and PySpark SQL concepts, right? Making data structured and working with different types of data and integrations, right? Yes. Fine. Now, so here RTDs. So we need to know something about the RTDs, right? Yes, RTDs. So here RDD, resilient distributed data set, what we call resilient distributed data sets. See, resilient distributed, what do you mean by resilient distributed data sets? Spark data objects, right? Spark data objects. Are called as RTDs. So we need to understand briefly about this RTD, right? Yes, Spark data objects we call it as RTDs. Again, these RTDs are subdivided. RTDs are subdivided. And these partitions, right? These partitions are distributed. So RTDs are subdivided into partitions, and these partitions again. Distributed across, they are distributed across multiple RAMs of multiple slaves. Multiple slave nodes, right? Multiple slave nodes. So Spark data objects we call RTDs. RTDs subdivided into partitions. These partitions are distributed across multiple RAMs of multiple slave nodes and are processed parallelly. And are processed parallelly. RTD programming style. RTD programming style is data flow. RTD programming style is data flow. You need to understand this properly. RTD and this data flow. What is a data flow? Data flow is a sequence collection of pipes. It is a sequence collection of pipes. What is a pipe? A pipe is a data operation. A pipe is a data operation, right? Yes. Data operations such as loading, such as loading data, transforming data, loading data, transforming data, filtering the data, grouping data, merging data, etc. Right? Yes. In Spark, observe here, pipe is a data operation such as loading, transforming, filtering, grouping, merging, right? In Spark, data flow is executed, right? Executed in sequence. That is RTD by RTD. That is RTD by RTD. One after the another, right? RTD by RTD. Data flow is executed in sequence, one after the another, with in-memory computation. With in-memory computing feature and persistence feature. In Spark, data flow is executed in RTD by RTD, one after the another, with in-memory computing feature and persistence feature. But if RTD has RTD has 20 partitions, assume that if a RTD has 20 partitions, then they can execute in parallel. They can execute. If RTD has 20 partitions, then they can execute in parallel. Yes. So observe here. RTD. Spark data objects we call it as RTD. R1 is an RTD. The output of this R1 will be the input to R2. The output will be the input to R2. Again, the output of R2 will be the input to R3. The R3 output also will be as the input to R4. So one output is the input to the next flow. One output is the input. One output is the input to the next one. This entire thing we will call it as a data flow. This entire thing we call it as a data flow. The output of one RTD. So this RTDs, all these 4 RTDs are there, cannot execute parallelly. All these 4 RTDs cannot execute parallelly, because to execute R2, compulsory the output of R1 should be collected. To execute R3, this R2 should have been execution should have been completed, and its output should be taken as input by R3. So here, this data flow, it won't execute all the RTDs at a time. So RTD by RTD, with in-memory computing feature. Okay. So this data flow to execute, we need to perform a action. If you perform action on R4 dot action, then only the entire flow will execute from the beginning to this R4, and R4 output will be collected. So here two RTDs can't execute parallelly, but if RTD1 has got some multiple partitions, it has got some partitions, P1 partition, P2 partition, P3 partition, P4 partition, multiple partitions up to P10. These partitions can execute parallelly. Partitions can execute parallelly, but RTDs cannot execute. And that too, this RTDs will be of bigger data volume. They cannot fit into the RAMs, right? If all the RTDs are loaded, then RAM cannot accommodate all these RTDs, right? Okay, fine. P1, P2, P3 up to P10. So whenever, see here, whenever R2, whenever R1 output is collected by R2, when R2 partitions loads and R2 computation finished, when R2 computation finished, right? R1 gets removed from the RAM. When R1 is ready, R2 is ready, R1 gets removed. Slowly, when R2 output is collected by R3, and R3 is ready, R2 gets removed from the RAM. When R3 is ready, when R3 is ready, R2, when R3 is ready and computed, right, R2 gets removed. When R4 is ready and R4 is computed, R3 gets removed. Means these many RTDs you cannot fit into RAM, so the previous one gets removed. And final R4 output, when R4 output is collected, R4 also removed automatically. Now what is in the RAM? Now which RTD is present within the RAM? No RTD within the RAM, you can trigger the next flow, right? This what the resilient distributed data sets, how they are going to get operated, right? Yes, understood everyone? Any queries in this? Whenever the next RTD ready, this current RTD will be removed, because all the RTDs cannot be loaded into a RAM, right? At a time. RTD by RTD, they get loaded and processed, right? The output will be given to the next flow. So Spark is a data flow. Spark data objects are called RTDs. RTDs are subdivided into partitions. Partitions are distributed across multiple RAMs. RTD programming style, data flow only. Collection of pipes. One pipe output will be the input to the next one. Okay. Now just observe this, right? Observe. On RTD, two types of operations can be performed. On a RTD, two types of on a RTD, two types of operations can be performed. First one, transformations. Second is actions. Transformation. Second is actions. Okay. Again, transformations, we have got three types of transformations available. Actions, if you perform action only, then the flow gets executed, right? And then only the flow is going to get executed. Observe this, the RTD computations, right? Yes. Transformations, right? On RTD, two types of operations can be performed: transformations, actions. First one, transformations. Three types of transformations. First one, each elemental transformation. Each elemental transformation, right? Yes. Second is like filter transformation, right? Each element, filter transformation, and aggregated transformation. Third one is what? Aggregated transformation. Example of each element transformation, right? Example like map, flat map. What do you mean by map and flat map? Means map means transforming each element name to start with uppercase character. So each and every record to be transformed, right? Filter transformation. What do you mean by filter transformation? Yes, filter transformation, right? Filter by range, filter, right? Aggregated transformation, group by key, reduce by key. Yes. Group by key, reduce by. And the filter transformation we use like filter and filter by range. Filter by range. We have got some inbuilt transformations. By applying this, we can directly get the result. No need to write huge codings, right? Yes. Two types of actions can be performed on a when an action is performed. What do you mean by actions next? Transformations and actions, right? When an action is performed on a RTD, when an action is performed on a RDD, then only the data flow will be executed. Data flow will be when an action is performed on a RTD, then only the data flow will be executed.
Sir, I just joined. If you don't mind, can you repeat from starting?
On a RTD, two types of operations can be performed. On a RTD, two types of operations can be performed, right? What type of operations? Transformations and actions. Transformations means each element transformation, filter and aggregated transformations. Each element means that If there are 1 lakh records, so all the 1 lakh records, the transformation is going to be applied. Filter transformation is based on condition, filter based on city, filter based on department number, filter based on some particular condition. Aggregated transformations means groupings, aggregations, right. So actions, when action is performed on RTD, then only the data flow will be executed from the root RTD. The following are some actions. The following are some actions. Collect, so what do you mean by collect, right? It collect all partitions, right? Data of different slaves, of different slave machines. Into client machine. And second, like we have got an example like RTD.collect. RTD.collect. If we collect all partitions, if we collect, it will collect all the partitions data of different slave machines into client machine. Collect is one, count is one. These are some of the actions. Count, take is one, save as text file. To save the result, save as text file. These are the actions. If you perform this action, these are some many, we have got many more actions later I'll be discussing, but whenever you perform actions only, RTDs are going to get executed from its root. What are that? Collect, count, take, save as text file. On a RTD, you know already RTD, right? Two types of operations can be performed. Each element transformation, filter transformation, aggregated transformations. When an action is performed on RTD, then only the data flow will be executed from its root. So, okay, count. Counts the number of elements in an RTD. In a RTD, right? Yes. RTD.collect. Take.
So, sorry to disturb you. Sir, when did the class start, sir?
Takes.
Hello.
Yes.
Yeah, sir, when did the class start? Sir, actually, I got the email saying that class will start at 4:30.
Yes. So this is for the new people, just a revision was done about what was discussed in the last session, right? So just this is what the types of, or two types of operations can be performed. This is what up to here we have discussed in the last previous session, up to this RTD's introduction, right? Right here, two types of operations can be performed: transformations and actions. Transformations means each element transformation, filter and aggregated transformation. Actions. Actions like collect, count, take, save as text file are some of the actions. Takes first n elements. Take means takes first n elements, right? N number of elements in a RTD, right? Takes n number of elements in a RTD. RTD dot take of 10. RTD dot take of 10. means takes the first 10 elements, right? Takes the first 10 elements, save as text file to save the output, right? To save the output. To save the output. HDFS, Hadoop distributed file system. Okay. So how this computation of, see, 1 second. R1, how this R1 is going to get created? R1 is a RTD. In Spark, everything is a RTD. How this RTD is created means if you're loading a file F1 file1.txt, if you're loading this file using Spark context using S, then this R1 is an RTD created. The R1 output, so R1 output as taken as input by the next one, R2. How you got this R2 on this R1? If you perform any operation, the output whatever we get is nothing but R2. Again, in R2, if you perform any transformation, the output whatever we get is the input to R3. Similarly, for R3, the output will be the input to R4. So in this way, this is the flow, data flow. So here, once all the 4 RTDs won't be loaded into the RAM. Once this is ready, this gets removed. When this is ready, this gets removed. When this is ready, this gets removed, right? Once the execution finished, the last RTD also gets removed. Now, the output, what is within the RAM? No RTD in the RAM. No RTD in RAM. Now, if you talk about the fault tolerance model, if I talk about the fault tolerance model, right? Yes. See how this fault tolerance is implemented within this Spark. So we have got a lot of discussion before we go with the practical part. First, you need to understand all this, right? Okay. Fault tolerance model. Fault tolerance model in Spark. Fault tolerance model in Spark, right? Yes. Case 1. Observe this case 1, everyone. When current RTD machine is down. When current RTD machine is down. So in Spark, so everything step by step I'll be showing you, right? Yes. When current RTD machine is down. Observe here. Observe this. Yes. So this is R1 is in Spark data object, RTD. RTD means Spark data object. The data is divided into multiple partitions like P1, P2, P3, assume. Yes, P1 stored in system 1, system 2, system 3, slave 1, slave 2, slave 3. The two where they are stored within the RAMs. So in Spark, totally RAM level storage and RAM level processing, because of which very high speed we can see in Spark, right? Yes. R1 output here, next the R1 output, whatever is taken as the input by R2. Data flow, the flow of, again, this it has got partition P1 available, P2 available, P3. This P1 stored in slave 1, slave 4, slave 5, slave 6. Suddenly, if this machine is down, try to observe. Here it is divided into 3 partitions, P1, P2, and P3. All 10 lakh records in P1, 10 lakh records in P2, 10 lakh records in P3. If slave 4 is down, slave 5 is down, right? Yes. Means 2 things we can observe here. There is some data loss. So how our Hadoop is, how Spark is able to overcome this PySpark, right? Yes. R1 into 3, R2 into 3, right? S1, S2, S3, S4, S5, S6. During the execution of the current RTD R2. During when current RTD machine is down. During the execution of current RTD R2. Assume this is R1. R2. If any one of the partition, if any one of the partition of current RTD during the execution of current RTD R2, if any one of the partition of current RTD is down, then all current RTD partitions P1, P2, P3 of R2 will be deallocated. Deallocated means cleared from the RAM.
Sir, can I ask a question?
Yes.
Sir, we are collecting a data from S1, S2, S3, right? And then after we are loading into the RAM via partitions. Then what is inside in S4, S5, and S6? Means there is another data or same data belonging to S1, S2, S3.
Here S1, S2, slave 1, slave 2, slave 3. Within the RAM, within the S1 RAM, P1 is stored. Within the S2 RAM, P2. Within the S3 RAM, P3 is stored. And within this S4, again this R1 output is collected as the input to R2. R1 output is collected as input to R2.
Yes, sir.
Again, it is stored in the 3 different S4, S5, S6.
Okay, sir.
In RAMs P1, P2, P3. When this R2 is ready, when R2 computation is finished, execution finished, this R1 totally gets removed automatically.
Means R1's output is collected by R2 and stored it in different machines, S4, S5, and S6. Then again partition those in 3 different P1, P2, and P3 and start execution.
So here, once this R2 is ready and this computation finished, the S1, S2, S3 what all the partitions available in the RAMs, right? Everything gets cleared.
I got it.
Okay, but here R2 R1 is there, R2 is there, but R2 into 3 partitions, still computation of P1, P2, P3 computation not finished. While trying to, the computation not completed, processing not completed. Still it is processing, means this partition 1, partition 2, partition 3 of S1, S2, S3, still they available or not?
No, it's not available because we are starting in R2. That's why the R1 data is totally gone. RTD first one is totally gone.
Until this total computation finished, still this will be available.
Oh, means total execution when we perform any action, then after total RTDs will gone.
So here, yes, when you perform action, action is performed, this is processing. During this processing step only, this particular machine S5 is down. If this S5 is down, still not totally processed. Until it is totally computation finished, then only this previous one gets removed. Now it is still not removed, right? So still it is not removed. Now what it will be done is, now if S5 machine is not, it's down, this P2 data is lost. P2 data is lost means there is no use of continuing this job further, right? Because the data is some data loss. So again, what it will do is, it is going to deallocate all the partitions. See, it is going to deallocate, it will be deallocated. All the current RTD partitions will be deallocated. So here I'm saying all the current RTD is R2. Its partitions are this, will be deallocated, means cleared from the RAM. Everything got removed now. Not only P2, P1, P3 also got removed. And reinitiated or reloaded in another slaves.
Means only R2 data.
Another slaves, only R2, yes. And reinitiated, reloaded in another slaves by taking the input, by taking the input from previous RTD R1, previous RTD. Understood what I mean? RTD. So still R1 is not removed, right? So what happens in R2, the partitions, everything, it will clear, and again it will take the output of R1 and it will be reinitiated, reloaded into another slaves by taking the input from the.
Sorry.
Let me complete. Then you can ask your question. Three partitions are stored in 3 different machines. 3 partitions are stored in 3 different machines. 3 different machines, excluding the machine which is down. Means you can store that partitions in any machines excluding the machine which is down. Understood, right? It's very simple. R2 partitions are there, one partition machine is down, so remove all the partitions, again take the output R1 output, the 3 partitions, again store in the 3 different machines other than the machine which is down. Now understood, right? Any queries in this, anyone? Case 1, when current RTD machine is down.
So sir, complete 3 partitions from the, 3 missions from the R2 will be removed, and again 3 missions will be added, and then will be executed. Is it like that?
So yes. So R2 data stored in the 3 partitions, P1, P2, P3, stored in system 4, system 5, system 6, right? Already system 5 is down. Means what you will do, as there is some data loss in this, so the other P1 and P3 also going to get removed. The partitions going to remove from S4 and S6 RAMs. And again, R2 is going to take from R1, the output is going to take the output. And R2, it stores that three partitions, P1, P2, P3, which is collected from R1. Either it will store now in R4, S7, S6 in different machine other than the machine which is down. Otherwise, it will take total 3 different machines. Understood, right?
Sir, means total process of R1 is gone and only output is reserved.
R1,
R1 has three partition. Na? When we collect the result from R1, then total the evaluation will be gone for R1, and we only collect the result.
so still R1 is available in the RAM, R2 is available in the RAM. Both are
R1
available.
is-
Once this total execution is successful of R2, R2 execution is successful, then only R1 total gets removed from the RAM.
Thank you, sir. Thank you. My point is clear now.
So, okay. Now one
Sir,
more.
one thing. Sir, now for executing the R1, we are using three systems, right? S1 and S2, S3. For executing R2, S4, S5, S6 for
Yes.
using. So, so R1 three systems and R2 three systems are different ones?
Different ones.
Different ones.
Yes.
Okay. Okay. So once maybe if we are going to R3, then R1 will be deallocated, right? R1 will be deallocated.
Once R2 execution finished, means
Complete.
R1 total R1 gone.
Yes, R2 execution is completed means R1 total missions will be deallocated. So those
Better.
missions will be again reused for R3.
Yes,
It
yes.
could be. Okay.
Yes.
Okay.
Now, one thing you need to understand before I go with case 2, right? Before I go with case 2, you need to have something about, I will discuss about this persistence in brief, right? But as of now, there is a concept called persistence. You need to understand about persistence. For example, there is a flow R1 output is taken by R2, R2 output is taken by R3. From R3, you got flows like this, R4, R5, R6, R7, R8, R9, R10, R11, R12. Totally, how many flows are there? This is one flow up to here. Flow 1. This is flow 2. Flow 2. This is flow 3. 3 different flows, right? Flow 3. Three different flows, right? Everyone understand? I want response. I want the sessions to be interactive,
Sir.
right? Everyone try to respond.
So I understand.
Flow 1, flow 2, and flow 3. 3 flows, right? R1, R2, R3 is here. Flow 1 is what? Everyone. Flow 1. Try to say R1, R2, R3, R4,
R4,
R7,
R7, R8.
R8. Flow 2, try to say what is flow 2?
R1, R2,
R1, R2, R3,
R3, R5,
R9,
R9, R10.
R10. Flow 3 is what?
R1, R2, R3,
R1, R2, R3, R6,
R6,
R11,
11, and 12.
R12. So I said Spark is a data flow language. Here there are 3 flows. I want to execute the flow 1. I want to execute this flow 1 means this entire flow I want to execute. Means to execute the flow 1, R8 dot action. Compulsory if you perform action, right? Then only the flow executes from the root IC. The flow will execute from the root. Now try to say R1. First R1 gets loaded into the, everyone try to observe how the process is happening. R1 partitions will be loaded into RAMs of different machines. So R1 partitions, different partitions of R1 loaded into different RAMs of different machines. Next, R1 output as input to R2, R2 to R3, R3 to R4, R7 as it. Now try to say the output of one will be the input to the next. When R2 computation execution finished, what happened? R1 will be, yes, removed from the R1 partitions. When R3 computations processing finished, all R2 partitions are going to get removed. Similarly, when R4, R3, total R3 is going to get removed. When R7, R4 partitions removed. When R8 execution finished, R7. Once this total output execution finished, the output of R8 will be the final output, which will be collected, right? And once the output collected, R8 also gets removed. Understood this flow, everyone? One by one RTD will be loaded. While loading and computed, the previous one gets removed. This is first flow. Flow 2, you see, observe this flow 2. If I want
Can I
to,
ask,
yes,
sir, R3 is RDD, which is used by flow 1 and also flow 3.
flow 2 also.
If R4 is ready with the result, then R3 will delete it.
Now check second, see the second flow.
Then my
No,
question
no.
is about what about R6?
Still we didn't see that is flow 3. R6 comes in flow 3, right? I didn't execute flow 3, right? Now I am executing flow 2 only. Observe here. R6 comes in flow 3. Still I didn't execute flow 3. Now I'm executing flow 2. Flow 2 means on which one I need to perform action. Generally we perform action on the last RTD. Or yes, right. Or
R10 dot action.
R10 data. Action means like count, collect, take. Just now I said some actions, right? Any one action you can. Whenever you perform this action, one by one RTD, first R1 loads. Next R2 loads. Next R3 loads. Next R5 loads. Next R9 loads. Next R10. This many RTDs cannot be accommodated. This many RTDs cannot fit into the RAM. You are already one RTD is a bigger data value. All these many RTDs cannot fit. First R1 only. Next R2 gets loaded. When R2 gets loaded and R2 computed, R1 gets removed. Now only R2 in the RAM. So now slowly what happens? R2 output collected by R3. R3 is ready. R2 gets removed, right? R2 gets removed. When R5, R3 also removed. When R9 ready and executed, R5 removed. R10. Once the execution finishes, R10 also removed. Now what is there in the which RTD is present within the RAM? No RTD, right?
Yes, sir. Yes, sir.
You got the output. That is what. And whether now there is no RTD in the RAM, next you can trigger the next flow, right? You can execute one more flow as there is no RTD. Flow 3 I will execute. Flow 3 will execute, right? Or 12 dot action means from R1, R2, R3, R6, R11, R12. So here when R2 is ready, computation finished, R1 removed. When R3 execution finished, R2 gets removed. When R6, R3, R11, R6, R12. Means here, what is your observation? All these are removed, right? Now no RTD in the RAM. Means here, in all the three flows, these three steps are common, right? In all the three flows, first three steps are common, right?
Yes, sir.
Flow 1 execution. Flow 2, why it cannot use R3 output directly? Flow
Because it
why
was removed from RAM.
it was got removed, right? So
Was get-
there is a concept called persistence in Spark. Persistence. So the flow means the RTD whose output is used by many flows. Persist that RTD. Persist that RTD means make that RTD available in the RAM. So whose output is mostly used by multiple flows here? Which RTD's output is used? R3 output, right? R3 output is used by multiple flows. If I say persist, I need to say like R3 dot persist using persist method. Then R3 get persist. R3 getting persistence means what do you? R3 gets available in the RAM even though the next RTD is ready.
getting up.
Even though the
Okay,
next
okay.
RTD is ready.
I
Now-
was read
now-
about that.
Now observe this. Now observe this, right? Now flow 1. Flow 1 execution. Now once flow 1. Flow 1 means what? I should say action on what? R. Everyone try to answer.
R1, R2, R3, R4, R7, R8.
R8 dot. I need to say what? R8 dot.
R8 dot action.
Whenever I say R8 dot action, R1, R2, R3, R4, R4, R7, R8. When R2 is ready, R1 removed. When R3 ready, R2 removed. But when R4 ready, is R3 removed?
Sorry,
No,
it's
not removed.
persistent.
It is persistent, so it won't be removed. It will be available. When R7 ready, this gets removed. When R8 ready, this also removed. This also removed.
Sir, while creating R3, then only we need to give this R3 dot persist.
What is it?
No, we are persisting R3, right? So while creating R3 RDD, then only we need to give this one, right? R3 dot persistent.
So just first you will be defining, you will be writing this entire code. One by one RTDs will be loaded.
Okay.
First you will be defining R1, R2, R3. But while execution, whenever you say action, right? Then one by one RTD will be loaded.
Sir, my question is, when do we need to mention that R3 dot persistent?
So here you will be writing the code, right?
Okay.
After writing R3 equal to R2 dot some transformation.
Yes.
After R3, you will say R3 dot persist.
Okay. Yeah, that was fine.
Now observe this first flow executed. What is present within the RAM? What is present within the RAM?
R3 and output.
R3 is available
R3.
in the RAM. Now, first flow executed means flow 2. Flow 2, no need to execute from the starting, no need to re-execute again all the steps, right?
Yes.
What is flow 2? R10 dot action, right? R
From R3.
It starts
R10
with
dot
R3.
Action.
R10 dot action. R10 dot action means R10 input is what? R9. R9 input is what?
R5.
R5.
And
R5 input is what?
R3.
R3. R3 is available in the RAM to give its output as input.
Yes.
So what is the flow?
R3.
R3,
R5.
R5.
R5, R9,
R10.
R10. This is
Yes.
the flow, right? Means no need to start from R1, R2. Why? Because R3 is available in the RAM. Whenever you say R10 dot action, first you will check from where I need to R10 need to get the input from. R9. R9 from R5. R5 from R3. R3 available in the RAM. Previously, now no RTD in the RAM. That's why the total flow executed. Now already R3 available, right?
Yes, sir.
Now when R5 ready, R3 won't be removed. When R9 ready, this will be removed. When R8 ready, this also removed. This also removed. Now again R3 is present in the RAM, right?
Yes, sir.
Now again if you say flow 3,
Yes.
right? Flow 3 don't need to re-execute from the beginning, right? As R3 is available, directly the flow can start from R3, right?
Yes, sir.
Yes, sir.
R3 output will be taken by whom? R6 directly. R6,
6 or 11 or 12.
R6, R11, R12. Means what is your understanding here? So when R6 steady, it won't be removed. When R11, this will be removed. When
This output where you can store, sir?
1 second. So R3 output is available in the RAM. So once all their execution finished, only R3 is available in the RAM. Only R3 is available in the RAM now. So if it doesn't want that R3 also, R3 dot unpersist is here. It gets unpersist. It also gets removed. Once your work is completed, you can unpersist it. Or when the server shutdowns, it will be unpersisted. When the session is closed also, it will be unpersisted, right? Understood. Any queries in this anywhere? What do you mean by persistence? Means what advantage we get means no need to execute. But here I got some in this way R1, R2, R3, R4, R5 up to R20 is there. First 20 steps common for all that flows. 3 flows are there for all first 20 steps. Means R20 dot persist, I can say, right? Understand? Hello?
Yes, sir.
R20 persisted means in the first flow compulsory it should execute total first to last. But from second flow onwards, R20 onwards, I need to execute, right? Means 20 steps decreased because R20 available, directly R20 output I can take.
R20 already has a data of R1 to R19. That's why there is no need of R1 to R19. Only R20 output is needed. That's why we are persisting those R20.
Yes. R20, why we are making persistence means making the RTD available in the RAM. So that is output used by many different flows.
Sir, like this, how many RTDs can we persist?
See here, persisting in RTD means making the RTD available in the RAM.
Available.
If already RTD is a very huge data object. To accommodate 1 or 2 RTDs only, you require huge RAMs. If you want to persist multiple RTDs and it doesn't want them to get removed means the upcoming RTDs cannot fit into the RAM.
Right.
Then
Then we need to highlight.
So you cannot store more RTDs in the RAM. If you have got a good RAM capacity only, you can do it.
Okay,
Huge RAM capacities.
got it.
There is a question there, like if you are not persisting, then what is the problem? Like if you are not knowing, suppose here pictorially I can say R20 is definitely connecting to multiple flows, but in the programming or while running RTD, we may not have that idea. Then what is the principle we need to follow to make one thing as persistent?
Very simple. I'll say a small task. Employees data is there, some employee records. From that employee records, slowly I transformed it, and finally R20 is nothing but I have extracted, for example, department number field I extracted and salary field I extracted. That is R20 step. R20 step is what? Department number and salary. So what is this flow? This flow is department number wise sum of salary. I want to calculate. This step is what? Middle one. Department number wise min sal I want. And this is what? Department number wise max sal I want. For all these 3 flows, you require department number and salary already available. This is what? Department number comma salary.
Okay.
Again, I no need to do all these 20 steps to compute to extract this department number and salary for this, right? Second flow and third flow. Already in the
Correct.
first flow, it is done. So I can directly take this department number and calculate the min salary within a single step. My job completes instead of 21 steps. Right? Understanding?
Yeah.
In this third flow also directly department number salary extracted, right? Already available in the RAM. It can take and performs max salary. But for this first one, compulsory the flow should be executed.
Okay. That
Means,
is the base.
but second and third time in the other for example, in the other we cannot reuse the here we can reuse the already executed transformations can be reused here. Understood?
Yeah.
So that's what if you want. Understood the
Suppose
persistence.
other way around, suppose if persist not used means what is the problem? Then in that case, normal execution.
Persistence is not used means second time, third time also you should
That
come from the beginning.
Nothing is okay.
No RTD present within the RAM. So you need to compulsory come from
recompute it. Okay.
re-execute all these things.
Okay.
Now come. So about the persistence I'll be discussing separately, right? As now series coming back to this case 2, right? Yes.
One question. I joined very late this lecture. Sir, partition is created by us, or means we decide how many partitions are there. Our system will automatically decide. It's a dynamic or it's.
See, once you have got a command, right? RTD dot get num partitions. It will return that. It will display how many partitions it has. For example, 2 or 3 or 4 or 5. It will use the result. By default, it will have some partitions. We won't do automatically. But if you want to control the partitions, if you want to set your own, right? How this first RTD is created, RTD1, how it is created. How RTD1 is created means whenever you are loading a file, file1.txt, file1.loading, you'll give the entire path. You're giving the entire path where that file is available, in which folder, in which drive.
So based on the file size, the number of partitions the system will design, right? At the initial level.
So here file1.txt is there. So using Spark context sc.text to file, you will load it. sc.text to file. You will be loading it. The path you will be giving within double quotes, right? This entire path where it is available. Comma 10, if you give 10 partitions, you will get. 5 means 5 partitions you will get. 7 means 7 partitions you will get. Means while loading only, we can give that number of partitions you want. Means by default, it takes its own, but if you want to set your own partitions, right? 10 or 8 or 7 or 6. Into means this indicates that how many partitions, right? Understanding? We can control the number of partitions in Spark. In Hadoop or other things, we cannot control the parallel processing, but here we can control. If you give 7 means it will be stored across 7 systems. If you give 10 means stored across 10 systems. Understood, right?
Yes, sir, yeah.
The number of partitions, whatever, while loading the file, RTD1 is going to take those many partitions while whatever you provide. Otherwise, it will take default partitions. How will you come to know how many partitions means? Just now I said there is a command RTD dot get num partitions. It will come to know. Otherwise, you can specify your own partitions. Case 2, observe this case 2. If previous RTD, if previous RTD is down. Means observe here, observe, try to understand the query first. If previous RTD machine is down, RTD1, RTD2, RTD3. Assume only one, some partitions S1 stored in S2, only one partitions only available. R1, R2, R3. Now try to answer this during execution of R3, during execution of R3, while taking input, while during execution of R3. While taking during execution of R3, while taking input from R2, during execution of R3, while taking input from R2. During computation of R3, while taking input from R2, if R2 failed, understanding, R3 taking R3 input is R2, while taking input from R2, suddenly R2 failed. Then during execution of R3, while taking input of R2,
Taking from R1, sir. R1 output.
observe, everyone try to answer. R3 is computed, is going to be computed. It's still not computed. R2 computation finished. R2 computation finished. When R2 computation finished, R1 is available.
No, sir. R1 is deallocated.
R1 is not available, right? It is removed from the RAM.
Yes.
So here, if while taking R3 taking input from R2, suddenly R2 machine down means, can R2 again, can it take the output of R1 and can it recompute? No, right? Because R1 is not available.
No, sir. When R2 complete, then only R1 is there. No?
Here R2 can't be reloaded. Here R2 can't be reloaded or reinitiated. Here R2 can't be, here 1 second, R2 can't be reloaded or reinitiated in other machines. Because R2 input is R1. Where R1 is not available. R2 input is R1. where R1 is not available, where R1 is not available in RAM. So here, just like the previous example, when R2 any one partition is down, then R2 can't be reloaded by taking input from R1 because R1 is not available where R1 in the RAM. So process should start from the beginning. So the process should start from beginning or from persisted RTD, if any RTD is persisted. Understood, right? Case 2, everyone? Any query in the case 2? Yes.
I understand.
So R1, R2 can't be reloaded as case 1 because R2 output is R1, but R1 not available in the RAM. So R2 cannot get output is input from R1. So it cannot, so the flow starts from the beginning. So one way this is good, one way this is bad. One good, how it is good means the flow starts from the beginning means the flow is executed, the job is getting executed. One way it is bad means already R1 and R2 R1 and R2 processed and compute. Again, when the flow starts from the beginning, again we need to recompute R1, R2, right? We need to reprocess it, right?
Sir, one question here.
Yes.
Sir, if in any of the RDDs, one system is down, then only we are making this process, right? Then we are getting back to previous RDD and getting the data again. Sir, will the Spark? I mean, the system is down, right? Will the Spark repair the system? I mean, will the restart the system in future, or it will leave the system alone?
So
as it is?
okay, the system is down later. Other than the system, as of now, it is going to reload into other systems. Later, when it is up, that system also can be used.
Okay.
Case 3. Observe this case 3, right? If a persisted RTD, if a persisted RTD machine is down, observe here, R1 is there, R1, R2, R1, R2, R3, R4, R5, 5 RTDs are there. In this one, R3 is persisted. This is stored in, there are only one partitions. Assume you have got only one partition for each RTD. Slave in slave 2, stored in slave 3, stored in slave 4, S1, S2, S3, S4, ES5, five systems, 5 RTDs. Yes. R3 is persisted. R3 is persisted. Now, which RTDs are available in the RAM? Now try see the flow and try to say how many RTDs will be in the RAM currently. Which are the two?
Only
R3 and R5.
R5, okay, still R5, okay. Assume that if R5 will be available. R3 also available, right? R3, R5 only available. Here, R3 stored in slave 3 and persisted. R3 stored in slave 3 and persisted. But suddenly, S3 is down. Suddenly S3 is down. R3 stored in slave 3 and persisted. R3 available in the RAM. But suddenly S3 machine is down. The persisted RTD machine only down. Then
Taking the data from R2.
it will be R2 be available. Is R2 available in the RAM?
No. Again, it has to restart from the first.
R2 won't be available, right? To take R2 output and recompute. So the flow. So the flow will be re-executed. Then the flow will be re-executed. Then the flow will be re-executed. From beginning or from the available source. Automatically. From the available source means if any other RTD is previously persisted from there onwards, automatically re-executed from available source automatically till R3 only. Till R3. Without performing action only, because when it gets persist RTD down means without performing action it will be re-executed, right, till R3, and R3 will be re-persisted. R3 will be re-persisted. And R3 will be re-persisted, right? Understood this step, everyone? If R3 down means again the flow starts from R2 to R3 automatically, and R3 gets re-persisted again.
Is when R3 is down, again we need to start the process from R1, R2, then R3, no, sir?
R3 and R3 will be persisted.
Yes, sir.
Once R3 persisted, its output available, then R4, R5 also gets computed.
Fine, sir. Thank you, sir.
Sir, if R3 is using 3 slaves, so and we are persisting R3, then those 3 slaves cannot be reused, right? Again, so those three slaves will be completely filled with data.
If 3 slaves, only 1 slave will be down, right?
Yeah, one
The
slave will be down.
other 2 can be used, right?
Sorry, I did not get you.
You are saying R3 partition stored in 3 slaves.
Yes, yes.
The 3 slaves assume that some S8, 9, 10.
Okay.
Means if only 1 slave down means that particular slave only cannot be used, but other 2 slaves are fine, right? Those can be used, right?
Right. But our data could be in other S8 also, right? The slave which is down.
R3 has 3 partitions. In that only 1 slave is down, means other 2 slaves are okay. Next again, if I execute the flow from the starting, R3 partitions they can be stored in the same other 2 slaves or different slaves it can use.
The same slaves it will use, and the whatever the failed slave, then it will attain a new slave.
Instead of that, a new
Failed
slave
one.
will be used.
Right.
Now observe this case 4 here. Everyone try to observe this case 4. Right. Here R3 persisted. Here case 4, if S4 is down. If S4 is down. If S4 is down means from where the flow should execute. So here let me say what is while executing R5, while computing R5, and while taking input. While computing R5, while taking input from while taking input from R4, if R4 is failed, then everyone, while computing R5, while taking input from R4,
Start from R3.
then everyone try to answer.
Start from R.
Yes. Then input is taken from R3, which is available. Then input is taken from R3, which is available in RAM. The input is taken from R3, which is available in RAM.
Vijay, if it is not persisted, then what is the case?
If it is not persisted, means it should start from the beginning. Again, R1, R2, R3, R4, everything need to be recomputed. Input
Okay.
is taken from R3, which is available in RAM. And reloading the partitions of R4. In other machines. And reloading the partitions of R4 in other machines in computing, right? And provides input to R5. Can we persist to what it is? Can we persist to what it is? Yes.
So it's possible, right?
R1, R2, R3, R4, R5. R6. R3 persisted, R5 also persisted. In this case 5 again, it's in that case 1. If R5 machine is down, if R5 machine is down, what happens?
Starts from R3.
If R5 machine is down, what happens is, what is it?
Starts from R3.
Yeah, flow will be re-executed. Flow will be re-executed from R3 to R5. From R3 to R5. If R5 makes the one, if flow will re-executes from R3 to and R5 will be re-persisted. R5 will be re-persisted. Understood, right? In this only case 2 again. If R3 machine is down,
It depends where are you now, means in which RDD you are working. If you are less than R5,
If R3 machine is down, from
you
where the
start
flow, for example, forget about case 1 now, observe this case 2. If R3 machine is down,
Starts from starting.
So starts from first.
flow will be re-executed, re-executed from
R1 to R3.
from R1 to R3, from R1 to R3 automatically.
but sir, it will differ now.
What?
Means we are working on R6 and we have a output of R5. Then we don't need a persistent RDD like R3.
So here, okay, R5 is persisted. R5 is persisted, but okay. Now see this. S4 is taking the input from S3. Forget still R5 and R6 not computed. S4 is loading into the RAM. During the loading, while taking input from R3, if this
At
S3 is
that time,
down, so that's what flow will be re-executed from R1 to R3 automatically. Automatically, we don't need to perform action, and R3 will be re-persisted, right? Understood that, everyone? Yes. Yes, understood that, everyone. So fault tolerance model, right? In Spark, and 2 types of things, transformations and actions. But I'll be discussing more on this RTDs, transformations, actions, and RTDs, lazy evolution, and persistence options, different ways of persisting, multiple ways of persisting, right? When to go for memory, when to go for disk, when to go for memory and disk. I mean, multiple options are there, right? And in that persistence also, we have got some rules to be followed. When the RTD will be persisted, and which RTD will be persisted, right? And after executing the flow or before executing the flow, we need to persist everything, that we need to follow some rules. Understood, right? This RTD fault tolerant model, right? And the computation of RTDs. So everything is RTD in Spark. Data object, fault tolerant model, right? So as of now, so as for this, right, I'll be stopping for now, and in the next week I'll be just start with some practical part. And but tomorrow, because of Christmas, there won't be any session, right? Because but next Saturday and next week I'll be sparing some extra time, as tomorrow we are losing some, there's no session because of Christmas. Next Saturday I'll be taking some extra session, 1 hour extra, right? Yes. So, and the students, right, still you should get enrolled, right? Everyone need to get enrolled. So to get added into the WhatsApp group and to get the videos and the notes, right, you are supposed to get enrolled by paying the fees, right?
We already have.
Doubt actually.
And
MLlib, which are all the topics we are going to cover.
Pardon?
Spark MLlib, which are all the topics we are covering. So the ML algorithms like classification, regression.
Yes, everything, all the topics I will be covering, right? Fine. Whatever we have discussed in the course content, everything is going to be covered.
Yeah, the content only specified MLlib. That's what I am asking. They have not mentioned clearly the algorithms which we are going to see.
Algorithm? No. Machine learning. We are not. MLlib means I'll be giving that how to work with using PYSPARK, right? Already you need to have this knowledge of this machine learning, right? Libraries, but I'll be sharing some libraries of this ML also, right? Machine learning libraries also.
Okay.
How to work with and how to use PySpark.
Mostly it is data engineering kind of thing.
But data engineering only, but not the total data science things.
That's correct.
It's again, it's a big course, right?
Yeah, right.
Fine.
And one more thing, I'm taking the Databricks certification exam actually. So do you think this coverage will definitely help me? No? Or
Yes.
Right.
Mostly for this data engineering only, right? Total of the concepts you can see there, right?
Yeah.
So,
Correct. Okay.
fine. Okay. Fine.
Sir,
So,
in this course, what are the you teaching, sir?
pardon?
In this course, what you are teaching, sir? PySpark means.
So PySpark, see, observe this. In this, I'm covering this total PySpark, Spark context, PySpark RTD parallelizing, PySpark RTD computations, persistence options, PySpark core computation, PySpark groupings and aggregations, various actions and transformations, right? Within this PySpark. And PySpark SQL, you can see like PySpark, lot of inbuilt functionalities available here. APIs, PySpark SQL, and data frame concepts, like many are there. There we don't write huge codings. By using this, we perform the operations. And PySpark SQL functions, aggregated functions, window functions, date, timestamp, and PySpark built-in functions, many built-in functions of PySpark, everything in brief. And also PySpark external sources, from the external sources, deployment modes, PySpark applications, right? Yes. And part of streaming ML integrations, right? Okay. Sir, how will we
Studying with Storm or Kafka?
Kafka?
Kafka. Okay. And which tool we are using? I mean, on this platform, Vijay, we are running these PySpark database communication.
So I'll be showing you on different environments, right? I'll be within the Yarn cluster, right? How we are going to execute, and also like I'll be showing you in Jupyter Notebook how to execute environment, and in Databricks also, right? Yes.
Thank you.
Right. Different environments I'll be showing. One second, hold on. Just give me a second. 1 second. So introduction to the RTDs and working of RTDs, right? But I'll be discussing one by one actions and one by one transformations in briefs. Here we have got many inbuilt transformations and actions. I'll be discussing one by one transformations and actions of this RTD in brief. And also about the persistence options and rules to be followed. I said what is persistence means making the RTD available in the RAM so that its transformations can be used by the other flows. Means already executed transformations output will be used by the other flows, right? Means no need to re-execute that already executed steps, right? So that is the advantage we get. And more on that persistence, right? What are the rules to be followed there? And we have got many persistence options, like where you want to persist in memory. In sometimes if your memory used by other RTDs unable to fit the persisted RTD, then you can also persist within the disk level, right? So what are the various options available there, right? Yes. And different ways of creating an RTD. There are 3 different ways for creating an RTD, right?
What is RTD, sir?
Resilient distributed data sets. Spark data objects we call as RTD. Spark data object we call it as RTD, right? So RTD again subdivided into partitions. So here I said in that today's introductory session, right? RTD means resilient distributed data sets. Spark data objects and RTDs are subdivided into partitions. Partitions are distributed across multiple ramps of multiple slave nodes and processed parallelly. RTD programming style data flow. Data flow is collection of pipes. At each flow, one pipe output will be the input to the next pipe. That is each data flow. So we can at each pipe, at each RTD, loading data, transforming data, filtering data, grouping data, merging data will be performed. Spark is a data flow. Two RTDs can never execute in parallel. But if the RTD has multiple partitions, those partitions can execute in parallel, right? Yes.
Sir, these notes you are giving separately or including recording, sir?
Yeah, so here you'll be getting, I'll be forwarding these notes, right? And we have got an online team
Please forward.
that the online team will be forwarding the videos. So you can go to the videos, right, everyone? These notes I'll be forwarding. Whatever notes I'm preparing, right, I'll be forwarding you. You can just, so in clear steps and even in the coming sessions, practical notes also in brief, clearly I'll be providing, right? Yes. And still those who have not got enrolled, right? You are supposed to get enrolled. Next Saturday, you will be getting a new link, right? Everyone, the link will be forwarded to only those who got enrolled, those who got registered, right? Those people to that mail IDs you can check. So get enrolled. So I will be stopping for now. Tomorrow because of Christmas. Pardon?
POC or any project we are doing?
Yeah. I'll be showing you one POC, right?
Okay.
So I'll be we'll be performing one POC.
Oh.
So yes, if anyone, right, not registered, not enrolled, right, you can just see in the chart panel now, the payment, that online team is forwarding the payment process procedure, and that if you're not got the link, right, even the contact details will be provided in this. Yes.
And weekends means is a 20
session type 30 or 40?
Saturday, Sunday.
So it 10 weekends, right?
Yeah, means Saturday, Sunday, 10 into 2, 20 sessions.
No.
Okay.
No. From next week, not like Saturday 2.5 hours, Sunday 2 to 2.5 hours I'll be taking on Saturday. Sunday also 2 hours. 2 means in a week you will be getting 4.
5 hours. Yeah.
4 into 10, 40 hours.
Okay.
Sometimes I'll be taking some 3-hour sessions also, right? At the last 3-4 weekends I'll be taking 3 hours.
Okay.
Based on this.
That's from
When class will start? 3:30 or 4:30?
Yeah, next week, right? The class starts at 4:30 in the evening, right? Next Saturday, 4:30 to 6:30. Right? Class timing will be 4:30 to 6:30, right? So yes, I'm stopping for now.
Okay.
You can see that.
Tomorrow class is there or not?
Tomorrow, because of Christmas, there is no session, right? Tomorrow. That's why I'll be, yes. Next week I'll be spending some extra hour, right? Yes.
Sir, you told that we require some basic idea of Hadoop and all. So you mentioned that you'll share those videos. Can you please share that?
Yeah. I'll also.
Maybe we can just go through that before we attend the next session.
Yeah, definitely. So I'll be just giving that basic like HDFS scoop, like basic HDFS Hadoop videos. Basic Hadoop videos I'll be sharing with you.
Yeah, sir.
You can just go through.
Share before we can just get prepared and come back.
Yes.
Sir, kindly share at least who have registered, right?
Yes. Yeah. Fine. Okay, fine. So I'm stopping for now and we'll continue on next Saturday, right? Will be the notes, the videos, everything you'll be getting, right? Yes. You can just be in contact with the online team.
Sir, will there be any weekday classes also?
What is it?
Any weekday classes for PYSPARK or?
As of now, there is no, but only for big data, Hadoop and Spark Scala is available.